So in question number 3, we're going to explore a question that we actually had started to explore in the previous lesson on compound interest, and that's what happens when you compound more frequently. Annually is once a year, quarterly is 4 times a year, monthly is 12 times a year. So naturally you might be thinking there could, in theory, be an advantage to compounding more often. That if you divide up your money into smaller, more frequent payments, you'll get more money in the long run than one lump payment once a year. And we did explore that pretty distinctly on page 16. We definitely saw that effect happen. Now, if you've already been under the impression that compounding more frequently is automatically a good thing, hopefully this question will simply open your eyes so that you can say, how much better is it? If you already think compounding more frequently is good, how much is the difference? Does the difference really end up being significant to the point where if you were going to invest your money as an adult, you would say to yourself, ooh, I know exactly what I should be looking for. I know exactly what I should be asking for at the bank. Because that's what I want to empower you to do, is to make smart decisions with your money so that you can understand the numbers that go into these decisions that the bank will ultimately offer you. The bank will control these things. You need to know what's going on, what important questions to ask, and what's happening to your money so that it's not a secret happening without your knowledge. Now in question number 3, we have a $10,000 investment, 4% annual interest. So those two quantities are basically going to be kind of fixed for us. No matter what we pick, we're going to get $10,000 initially invested, and it's going to have a 4% interest rate for sure. We're going to invest for a 10-year period. So I'm starting to think now, how can I make sure that I understand which parts of this compound interest formula they're giving me? I'm going to use the compound interest formula just because I like using the compound interest formula. I feel like it has some structure to it, and I personally like using formulas because they have structure, and I feel like that's more secure. But you can obviously do this without if you choose to. Now, I'm going to start with the first row in the table, and I'm going to fill in what I know. If I'm compounding annually, for example, that's 1 time a year. N is, remember, the frequency of your investment per year. N is going to pay you 1 time per year if you go annually. Quarterly would be 4 times per year. Monthly would be 12 times per year. So you can fill in the columns vertically or horizontally. It's up to you. I just kind of wanted to give you a heads up so you know what N means. N is the number of times per year that the bank is going to kick you some money. Now, going back to my annually example here, P is the principal amount. The principal amount is the initial value. That was the $10,000 investment, so I'll write 10,000 there. R, we said in the previous question, is the interest rate. Now, the interest rate needs to be represented as a decimal. So since they gave us 4%, I'm going to write my interest rate as 0.04. T is time. I'm going to invest for a 10-year period. So T is 10. And the value of the account is essentially like the answer. So this is where I'm going to write everything out, and then I'll type it into my calculator. Some people don't write it out first. They just go ahead and type right off the bat, and that's fine if you have the calculator and the dexterity to do so. If you want to, though, you can basically copy the equation, plug in the numbers as you go, and then type what you wrote afterwards. So P, 10,000, times 1 plus R, which is 0.04, divided by N, which is 1, to the power of N, which is 1, times T, which is 10. Now you can clean this up or you can type it in as is. I'll leave that as a choice that you can make for yourself. For example, 0.04 divided by 1 probably feels a little bit redundant to type in, like dividing by 1 is just 2 extra characters you don't need to type, but I'll leave that as your choice. So 10,000 times, and this is where I want to be a little bit disciplined, 1 plus parentheses 0.04 divided by 1. Now notice I put that fraction as parentheses. If you thought, perfect, that's ridiculous, you just typed all these extra characters for nothing. It's fine, do what you want to do. Then you raise it to the power of, and I always use parentheses around multiple things inside of power as well, N, which is 1, times T, which is 10. So I plugged into my formula, and now I got 14,802 So a good investment for sure, because if I invested $10,000 and now I'm up to $14,000, that's certainly worth my time. 10 years worth of time and I made $4,000, that's pretty awesome. Now, let's think about quarterly. Let's think about what would change and perhaps what would stay the same. If I did this quarterly, I still have the same principal investment, $10,000. I still have the same interest rate, still 0.04. I'm still investing for 10 years. The only difference is the fact that N is now 4 times a year instead of just 1 time a year. So let's see how that would look if I plug that into the equation. Still the same initial investment, 10,000. 1 plus, that's part of the formula. Rate is still 0.04. Divided into 4 segments, because that's my N, to the power of 4 times 10, which reminds me that, oh yeah, it's quarterly. That's why I'm multiplying times 4, because there would be 40 quarters in 10 years, so that makes sense. And now you can utilize, if your copy and paste feature on your calculator works, the copy paste feature, you can press second enter. That copies everything you did from the previous line, and you can just change only the details that needed to change. For example, I'll change the 1s to 4s, everything else stayed the same. And that gives me my next answer, which is 14,888.64. I'm not surprised. I expected this to be better because I was compounding more frequently, and sure enough, I made an extra $86. That's what I come to expect from compounding. I should be making more money the more frequently I compound. Let's try one more just to make sure we got it. 12 months a year. If N is 12, P is still the same, R is still the same, T is still the same. You don't even have to recopy those things. You can even just go straight to your calculator and make those quick changes. Now you have a 12 instead of a 4. Easier said than done sometimes on some of these calculators, but now I can see, not surprisingly, another bit of evidence to suggest compounding more frequently is paying me bigger numbers. That's what I expect. So see if you can do the rest of the table. You need to figure out, of course, how many weeks are in a year, how many days are in a year, how many hours are in a year, and how many minutes are in a year. If you can't think about the math on that, you can always Google it if you need to. But see if you can figure out the value of the account, because the question I want to pose to you is, how much better can this really get? If it's just going to keep getting better and better and better, my investment's going to keep growing and growing and growing, like by minute, what's that going to look like? And would it be more advantageous to go by second, by millisecond, by nanosecond? Do I need to start thinking about crazy short increments of time? What's going to happen? So fill out the rest of the table and make some observations to see if you can notice any sort of relationship here.